Did you know that every day Earth collects between 5 to 300 metric tons of space dust? That's equivalent to an elephant falling from the sky every day. But what is this space dust we're talking about? It's a cosmic lint, a mix of tiny fragments from asteroids, comets, and even from the birth and death of stars. These minuscule particles are not just in our backyard of the solar system, they're scattered throughout the universe. Think about it. The universe in its vastness is essentially a dust-filled vacuum. These particles might be tiny, but they play a significant role in shaping the universe as we know it. From the atmospheres of planets to the formation of new stars, and even the phenomena of beautiful meteor showers, space dust is an unsung hero. So let's dive deeper into the universe's tiny particles and their big impact on our solar system. Space dust plays a crucial role in shaping planetary atmospheres, including the one we breathe in. Picture this: billions of tiny particles, invisible to the naked eye, hurtling through space at breakneck speeds. These are not just particles, they're cosmic travelers journeying from the farthest reaches of the universe. We call this interstellar and interplanetary dust. But what does this space dust have to do with our planetary atmospheres? Well, a lot more than you might think. Space dust is constantly raining down on our planets, and this influx of material can have significant effects on a planet's atmosphere. In fact, it's estimated that every day, around 100 tons of space dust descends upon Earth. Now, you might be wondering, how does this affect our atmosphere? When space dust enters a planet's atmosphere, it often burns up, releasing gases. These gases can alter the composition of the atmosphere, adding elements that weren't there before. For instance, on Earth, space dust is a source of iron and other nutrients that can influence the growth of life, including plants and phytoplankton in our oceans. Moreover, space dust can also affect a planet's weather and climate. As space dust burns up in our atmosphere, it can create trails of condensed water vapor, which can contribute to cloud formation. Over time, the cumulative effects of these tiny particles can even influence a planet's climate, with potential impacts on temperature and precipitation patterns. But it's not just Earth. Other planets in our solar system, like Mars, also have their atmospheres shaped by space dust. In fact, space dust is thought to play a key role in creating Mars's thin, carbon dioxide-rich atmosphere. So, as we continue to explore and understand our universe, it's clear that these tiny particles, these specks of dust, hold much more significance than their size might suggest. They're not just dust. They're cosmic architects, shaping and influencing the atmospheres of planets across the universe. So, the next time you take a breath, remember, you're inhaling a bit of the universe. Ever wondered what causes those beautiful meteor showers that light up the night sky? Well, the answer lies not in some grand cosmic event, but in something much more humble: space dust. Yes, those spectacular streaks of light are actually the fiery ends of tiny particles from space, burning up as they enter the Earth's atmosphere. Space dust, or interplanetary dust particles, are tiny fragments of comets and asteroids. As these larger bodies orbit the Sun, they leave behind a trail of dust. When the Earth, in its own orbit around the Sun, passes through these dust trails, we experience what is known as a meteor shower. Now, you might be wondering, why does space dust burn up as it enters our atmosphere? The reason is friction. As these tiny particles, traveling at high speeds, hit the atmosphere, they encounter resistance, or drag. This causes them to heat up, glow, and disintegrate, creating those brilliant streaks of light we see from the ground. Meteor showers are named after the constellation from which they appear to originate. For instance, the Perseid meteor shower, one of the most popular meteor showers, seems to originate from the constellation Perseus. However, the source of the Perseids is actually the comet Swift-Tuttle. Each year, when Earth passes through the dust trail left by this comet, we get a spectacular light show in the form of the Perseid meteor shower. Meteor showers are not just a beautiful spectacle, they also provide valuable insight into the composition of comets and asteroids. The dust particles that burn up in our atmosphere are essentially unchanged since the formation of the solar system. By studying these particles, scientists can learn more about the early solar system and the processes that led to the formation of planets. So, the next time you see a meteor shower, remember, those shooting stars you wish upon? They're actually tiny particles from space, remnants of comets and asteroids, giving us a glimpse into the history and mysteries of our vast universe. Stars, the twinkling lights in the night sky, owe their existence to space dust. Have you ever stopped to wonder where stars come from? They're not just floating lights that appear out of nowhere. They're born, they live, and they die, much like us. And the birthing place of stars, my friends, is none other than space dust. Let's take a journey into the cosmos and unravel the mystery of star formation. Picture vast clouds of dust and gas, light years across, floating in the infinite expanse of space. These are called nebulae, the stellar nurseries of the universe. When conditions are right, these nebulae collapse under their own gravitational pull, creating dense pockets of material. This collapse isn't sudden, but rather a slow and gradual process that takes millions of years. The dust and gas are drawn together, growing denser and hotter as more material is pulled in. This causes the center of the cloud to heat up to extreme temperatures, creating a protostar. As the protostar continues to grow and the temperature rises, a process known as nuclear fusion begins. The intense pressure and heat cause hydrogen atoms to come together, creating helium and releasing a tremendous amount of energy in the form of light and heat. This is the moment when a star is truly born, shining brightly in the cosmos. It's amazing to think that every star you see in the night sky, including our own sun, began its life as a cloud of dust and gas. These tiny particles, scattered across the universe, are the building blocks of stars. They create the stunning tapestry of the night sky that has captivated humanity for millennia. So the next time you look up at the night sky, remember that it's not just a beautiful sight, but a testament to the power and wonder of space dust. It's the raw material of the universe, forming not just stars, but galaxies, planets, and potentially life itself. Remember, without space dust, our night sky would be dark and devoid of stars. Not only does space dust give birth to stars, but it also plays a pivotal role in the formation of planets. You might be wondering how something as small and insignificant as dust could be responsible for creating the massive celestial bodies we call planets. Well, it all starts with a process known as accretion. Accretion is a phenomenon that occurs when particles of dust and gas in space collide and stick together. This might sound simple, but when you consider the vastness of space and the sheer number of dust particles floating around, it becomes a little more complex. You see, space dust isn't like the dust you find under your bed. It's made up of various elements, including iron, carbon, silicon, and other compounds. These particles are incredibly tiny, about 1,000 times smaller than a grain of sand. Now imagine millions upon millions of these minuscule particles floating around in space, colliding and sticking together. Over time, they form larger and larger clumps. These clumps then attract more dust and gas through their gravitational pull, growing even bigger. This process continues, with these clumps growing larger and larger over millions of years until eventually they form planets. This is precisely how our very own Earth was formed. Around 4.5 billion years ago, a cloud of gas and dust began to collapse under its own gravity. As it did, the particles within this cloud began to collide and stick together, forming larger and larger clumps. These clumps eventually grew into planetesimals, the building blocks of planets. Over time, these planetesimals collided and merged, forming the Earth we know today. So next time you look up at the night sky and marvel at the beauty of the planets, remember that they all started as tiny particles of dust floating around in space. It's a humbling thought, isn't it, that the grandeur of the cosmos was born from something so small and seemingly insignificant. So space dust is literally the building block of planets. It's a testament to the incredible power of nature and the fascinating processes that occur in the vast expanse of space. Comets, those icy visitors from the outer regions of our solar system, have a deep connection with space dust. They're not just the spectacular celestial phenomena we gaze at in awe, but also intriguing subjects of study for astronomers. Let's delve into the interplay between comets and space dust. Comets are often called dirty snowballs by scientists, and for a good reason. They're composed of a mixture of water ice, frozen gases, rock, and a considerable amount of space dust. When these cosmic snowballs journey close to the sun, things get really interesting. As a comet approaches the sun, it begins to heat up. The icy nucleus starts to sublimate, transitioning directly from a solid to a gas, bypassing the liquid phase. This process releases the embedded space dust particles, which are then carried away by the solar wind, forming a glowing envelope around the comet known as the coma. But the spectacle doesn't end there. The dust and gas continue to stream away from the comet, creating two distinctive tails. The dust tail, which is what we usually see when we look up at a comet, is composed of tiny dust particles reflecting sunlight. This tail is broad and curved following the comet's orbit. The other tail is the ion tail, composed of ionized gas, and it's blown directly away from the sun by the solar wind. This tail is straight and narrow, always pointing away from the sun, regardless of the comet's direction. So, every time a comet swings by, it leaves a trail of space dust in its wake. This dust can continue to orbit the sun, becoming part of the interplanetary dust cloud. It can even make its way to Earth, contributing to our planet's collection of cosmic dust and occasionally producing meteor showers. But comets are more than just cosmic dust dispensers. They're also ancient relics, preserving the primitive material from the early solar system. Studying them and their dust can provide valuable insights into our cosmic origins. So, the next time you see a comet, remember it's a space dust dispenser. And it's not just dispensing dust, it's sharing the stories of our solar system's past, one dust particle at a time. Space dust may be tiny, but it poses a big challenge for space travel. Imagine driving at high speed on a highway where even a pebble can cause a crack in your windshield. Now imagine the same scenario, but in space where even a particle as small as a grain of sand, traveling at speeds of up to several tens of kilometers per second, can potentially cause significant damage to a spacecraft. That's the reality of space travel, and the hazard that space dust presents. This inconspicuous cosmic debris floating around in the void of space is not as harmless as it appears. When a spacecraft travels through this dust-filled space, the tiny particles can strike the spacecraft with such force that they can cause considerable damage. This phenomenon, often referred to as hypervelocity impact, can lead to the creation of minute pits on the spacecraft's surface, compromise its structural integrity, and even cause catastrophic failure in the worst-case scenarios. The danger isn't limited to unmanned spacecraft either. Astronauts embarking on spacewalks are also at risk. The spacesuits they wear are designed to protect them from the harsh conditions of space. However, they are not completely immune to the threat posed by space dust. These minuscule particles can cause damage to the suit's material, and in some cases, can even penetrate it, leading to potential breaches. There are measures in place to mitigate these risks, of course. Spacecraft are designed with special materials and shielding to withstand the impact of space dust. Spacesuits, too, are constantly being improved to offer better protection. Nonetheless, the hazard remains, a silent reminder of the challenges and dangers that come with venturing into the unknown. In the grand scheme of things, space dust, often overlooked in the face of more obvious threats like radiation and microgravity, serves as a stark reminder of the complexities and challenges of space exploration. It's an interstellar sandstorm that we must navigate as we reach for the stars. Space dust, it turns out, is one of the unsung hazards of space exploration. From shaping planetary atmospheres to forming stars and planets, space dust has a surprising impact on our solar system. This ubiquitous cosmic dust, despite its minuscule size, plays a powerful role in the way our universe functions. Let's take a moment to recap some of the remarkable ways space dust influences our solar system. To begin with, space dust contributes significantly to the formation and evolution of planetary atmospheres. These tiny particles, when they fall into a planet's gravitational pull, burn up in the atmosphere, leaving behind a trail of atoms that can affect the planet's climate over time. On a grander scale, space dust is the raw material that stars and planets are made of. These interstellar particles coalesce over billions of years, forming dense regions that eventually ignite to become stars, and around which planets take shape. It's a cosmic dance, choreographed by dust. Space dust also puts on a spectacular show for us on Earth in the form of meteor showers. When Earth passes through a stream of space dust, we see a flurry of shooting stars streaking across the night sky, a beautiful reminder of the cosmic processes happening far beyond our planet. Additionally, these tiny particles are closely linked to the existence of comets, those icy bodies that traverse our solar system. The dust in a comet's tail is essentially space dust that's been heated by the sun and ejected from the comet's nucleus. Finally, space dust poses both challenges and opportunities for space travel. While it can damage spacecraft and astronauts' equipment, it also provides valuable information about the composition of our universe, helping us to better understand the world beyond our own planet. So, as we've seen, space dust is much more than just dust. It's an essential ingredient in the cosmic recipe, shaping the universe as we know it. So the next time you look up at the night sky, remember, you're looking at the work of countless tiny particles of space dust. Your journey with space dust doesn't end here. As part of our cosmic community, you play a crucial role in this astronomical adventure. If you've learned something new from this video, or if you've been amazed by the remarkable role of space dust in our universe, then we invite you to be a part of our growing community of space enthusiasts. Give this video a like and share your thoughts in the comments section below. We'd love to hear your opinions, questions, or even your personal experiences with stargazing and meteor showers. Don't forget to subscribe to our channel and press the bell icon so you never miss out on our exploration of the cosmos. And remember, sharing is caring. So share this video with your friends and family and invite them to join us on this journey through space. After all, the more we understand about our universe, the more we can appreciate the spectacular cosmic dance happening right above our heads, choreographed by countless tiny particles of space dust.